Welcome back. Today we're going to discuss Java collections, which is going to bring together our discussion of the Java array list and object-oriented programming principles in general. So the Java array list that we spent quite a lot of time on is part of the Java collections hierarchy. So with this, we're going to see how the array list fits in that category, but we're also going to begin to learn how to read and understand an object hierarchy, a very important topic to you because the standard libraries that you're going to encounter in your career, whether in Java or C# or in any other object-oriented programming languages, are built this way. So they tend to be large object hierarchies and built, as I've said, as inverted trees from the beginning. In Java's case, object is at the top of this inverted tree. And when if you see a diagram of the entire Java hierarchy of the class library, it's huge and intimidating. So, but that's not the way you understand it. You understand it branch by branch. So today we're going to understand a little bit more about the collections branch and then how the array list fits within that branch. So recall the four characteristics of an object-oriented programming language: encapsulation, inheritance, polymorphism, and abstraction. All of those are going to be on display as we look through the collections hierarchy. So here we are. And this is not the entire collections hierarchy. This is just a subset of it. The one I want to discuss today, and we can get down to the array list here. So at the top of the hierarchy is an interface called a collection. Recall what an interface is. It's a set of promises or a programming contract. No implementation. But when you say you inherit from that interface, you've got to develop the methods of that interface. Then also an interface is the list down here. So a list inherits in turn from collection. So by the time you get to the actual concrete class here, which inherits directly from list, but it also inherits from collection. So when you understand what's in collection and when you understand list, you understand a lot more about how the array list behaves. Also, we're going to discuss the queue interface here and the linked list here. The linked list, you should expect it's going to look a lot like the array list from looking at this diagram. Why? Because it inherits from the same interfaces, right? It also inherits from the queue interface too, so that adds some additional characteristics to the linked list that the array list doesn't have. So the interface at the top, the collection interface. You can see you have add all. What is the size? Is it empty? Does it contain this object? Does it contain all of this object and pass to another collection? You can iterate over the members, so the for each loop works on it, right, from beginning to end. You can add members, and you can also remove members. Remove a single object or remove a collection of objects. You can clear the entire collection. So, and you can also convert the collection into a fixed array. Notice here you have the idea of a collection of objects, but there's no notion of an order or an index yet. So let's look at our diagram again. The collection's at the top, and that defines a group of objects, the collection. When we get to the interface list, now we have the idea of an order by index to the collection. Notice these methods: add, get, remove, set, sublist. All of them have the idea of an index. So add at this index this object or this element. Get at this index. Remove at this index. So the interface list adds to the notion of collection the idea of indexing. So again, reviewing our diagram: collection at the top, and then list inherits from collection, also an interface, not an implementation yet. Okay. So the queue interface over here, over on the right-hand side here. What does the queue interface do? It's a collection for ordering task processing. It's not really a standard computer science queue. A standard computer science queue would have in-queue operations and dequeue operations, something like that. Add something to a queue, take something out of a queue. And a queue, the behavior of a classical computer science queue is like a line at a grocery store or a line at a bank. It's first in, first out. So as you queue elements in the list, you can put them in a processing order by the queue. Now, the Java queue is really a more general idea of a processing list because it also supports a stack as well. A stack is a first in, first out. So a queue is a line, an order. A stack is an inverted order, first in, first out, like a stack of plates in a cafeteria. So a queue would have operations like on queue, get in line, dequeue, get out of line, whereas a stack has operations like push and pop, think of a stack of plates at a cafeteria. A stack being the first in, last out operation. So those are normally expressed with push and pop. So then the class array list that we've used a lot. Remember, the array list is an implementation of the collection interface, which is the idea of a group of objects. And then it also implements the list interface, which this is the idea of ordering by index. Internally, it holds data in a contiguous block, like a Java array. However, it adds functionality to the Java array in that it can grow and shrink dynamically as needed. It provides fast iteration and fast random read and write access. You'd choose it over a linked list when you need fast iteration, but aren't as likely to be doing a lot of insertion and deleting at random locations in the list. We're going to discuss linked lists in a little bit and get more into, well, when do you use a linked list and when you use an array list in a computer application? And we'll get into that in the next lecture.